thought a few of you might want a couple of more examples with the chain rule, and I'll try and do this with some colours so you can sort of see where I'm really coming from. So basically, when you have a function of a function, so a function wrapped up inside another function, you have to use the chain rule. So I'm going to rewrite the first example using some colours to show you the two different functions. So if we call it y is equal to, I'm going to call the function to the power 4 in purple. I'm going to write the function that's inside the brackets, x plus 3, in red. So you can sort of see how there are two different functions here. One is the power 4 function, and the other one is the x plus 3 function in the middle. Okay, so the chain rule basically says that dy dx, I'll write it up here, so dy dx is the same thing as dy du times du dx. So basically you have to differentiate both the functions and multiply them. Okay, so if we differentiate the whole thing, so the sandwich, it'll be 4 and then something to the power of 3, because I reduced the power by 1 and it comes out the front, and then so it's reducing the power by 1, so 4 minus 1, the 4 goes out the front, and so we've got something to the power of 3. The thing inside stays the same because I didn't do anything with that. Now I need to times it by the derivative of the inside bit. Now the derivative of x plus 3 is just 1, which gives us our final answer, which is 4x plus 3 to the power of 3. Now that one was a bit straightforward because the derivative of the inside was 1. Let's look over on the right hand side here to our next example. Let's rewrite it again as y is equal to, now I'm going to do in purple the whole function, which is 3 times something to the power of 9. The inside bit I'm going to do in red again, so it's a different function, the 5x plus 9 in the middle. So you can see what I call the sandwich. The purple's the bread, and the red is the filling of the sandwich. Now, what I'm doing here is I'm saying the derivative, dy dx, is equal to, well, let's differentiate the whole function first. So it'll be 9 times 3, and the purple bit will go to the power of 8 because it stays, it reduced the power by 1 and the power goes out the front. The inside bit will stay the same. It'll still be 5x plus 9. And then we're multiplying by the derivative of the inside. Now the derivative of 5x plus 9 is 5. So this function then becomes, or the derivative function becomes 27 times 5, which is 135, times 5x plus 9 to the power of 8. Okay, so I differentiate the outside bit first and the inside bit second. Oh, in my first example, I should have called this dy dx because it's not the same function, it's not just equals to. Okay, the final example. Now this one's a little bit tougher to see, but it's the same idea. So we've got y is equal to, well, it's something all to the power of 4. That's my sandwich, if you like. I then have a function in the middle, which is 2x cubed plus 3x in the middle. So my filling is 2x cubed plus 3x, and my sandwich is everything to the power of 4. So now to differentiate that, dy dx is equal to, well, it'll be the whole thing to the power of 3, and the 4 will come out the front. So if I'm just thinking about it as something to the power of 4, the 4 comes out the front and the power gets reduced by 1. The thing in the middle stays the same, 2x cubed plus 3x. Now this is now times the derivative of the filling. Now the filling was 2x cubed plus 3x. So the derivative of that will be 6x squared plus 3. Remember, the 3 times by the 2 and the power gets reduced by 1, giving my 6x squared, and the derivative of 3x is just 3. So the final result will be 4 outside of 2x cubed plus 3x to the power of 3 times 6x squared plus 3. I could expand it if I wanted to, but it doesn't help me by expanding it. So with all these chain rule problems, you've got to look at it as something in the middle I have to differentiate and the whole outside function and multiply those two derivatives. Hope that helps.